Hi, and welcome to the eBPF and Cilium Office Hours live stream. This is episode 95. I'm speaking to you today from Zurich in Switzerland, where I've been visiting some of my isovalent colleagues. So that's why I have a slightly different background today. Before we get into the main business of 1.14, just really one main announcement to make, which is... Well, first of all, let me just remind you that the show notes are in HackMD. So if you follow the link in that corner, you can find these show notes. And eBPF Summit. We have announced the date for the 2023 edition. It's going to be on September the 13th. So block that out in your diaries. Register so that we can send you reminders nearer the time. And perhaps most importantly, if you've got a story you'd like to share, some interesting information about eBPF, if you'd like to talk about what you've been doing in eBPF, then the call for papers is open. So it's going to be open until, I think it's July the 21st. And yeah, we'd love to hear what you've been doing with eBPF. All right. As always, if you're watching us from anywhere around the world, do say hello. We always want to, it's always lovely to see where you're watching us from and to hear your comments. And in particular today, we're going to be looking at some demos from Cilium 1.14. We probably don't have time to see all of them. So we'd love to get your comments on which of the features you'd be most excited to see. So without further ado, let me bring into the stream Nico. So welcome, Nico.
Hi, everyone. It's good to be back. Always a pleasure to be here.
Thanks for joining us. And thanks for setting up. I think you've put together quite a lot of different demos of quite a lot of different features. And we'll see what we can get through today. I'm hoping the comment thing is working because at the moment I don't see anything. So if you are watching, say hello and let us know that you can see us. So in the show notes, we've got a list of a few, let's say a large handful of features that we're able to demo today. There's also a bunch of other features coming up in 1.14 that we're not going to show today. There are some things related to service mesh, for example, that we thought we'd save for another edition. So, Nico, before we get into the demos, maybe just tell us what you're kind of most excited about in 1.14.
Oh, wow. Well, outside of the very exciting new service mesh stuff, I guess what I love about working open source is that you can see everything happening. So there's nothing being hidden. So if you want to go and try out the new features, you just go and check out the release notes. And, that's what I've been doing over the past few months is, oh, I like some of these features. I go and play with this. Being a network guy, I love all the new BGP stuff. I just can't help myself. It's very geeky, but maybe we'll have some time to look at it. I'm a big fan of the Gateway API, and every time there's a new type of feature supported by the Gateway API, I'm always happy to go and try it out, and we might have a look shortly. Everything is pretty cool. WireGuard is awesome. So which one should we start with?
Let's just bring up the list quickly. So it's basically this set of, starting with Gateway API TLSRoute. There are a few WireGuard things. There are some BGP enhancements. There's Envoy is a daemonset, which personally I'm pretty keen we get to show. So I hope we get to that one. And custom node config for migration. So those are the broad areas. If you're watching and one of those particularly piques your interest, then let us know. I'm just going to quickly say hello to a few folks who've said hi. So hi to regular viewers like Russell. Hi, Andreas. Good to see you, Nikolai. And the Corsair has joined us. Great to have you with us, Nino. Okay. Shall we start at the top of the list and look at the Gateway API TLSRoute feature? That seems like a good place to start.
Let me go share my screen.
Yeah.
And, as I just mentioned, all of this is, you can go and try many of these features when you're at your convenience. We started with regular snapshot releases on the start. The first one was snapshot 0, which was about maybe 3 months ago. And again, you can see also list of features, major changes, minor changes, bug fixes. But we'll start with Gateway API. Now, many of my demos are based on some of the labs that you may have seen before. And the labs, most of these labs will actually be public, again, by the time 1.14 is released. So you can go and try it in this kind of managed, dedicated environment.
Right. But if people couldn't wait, they could take the current latest code, and all of these features are in the main branch now, I think.
Yeah, exactly. Yeah. So some of the demos are, for example, I'm using snapshot 3 here for some of the Gateway API stuff, but we'll see a few different images. Cool. So Gateway API, we've had a few sessions about it. You had some sessions with Nick Young, who's one of the leaders of the project. We've seen some of the features already, which Gateway API is a kind of next generation ingress, how you route traffic into your cluster. And typically it's like HTTP traffic or HTTPS traffic, and you route depending on some header or path or some kind of criteria, and you route it to a specific service, and you do some load balancing, etc. What we've seen before with the Gateway API was where we terminated the TLS session at the Gateway API itself. So if I'm an external client and I'm running HTTPS sessions to this hostname, HTTPS will be all the way up to here, and then it will be unencrypted standard HTTP to my Kubernetes pods and services. And also kind of certificates will be kind of managed at the Gateway API level.
Right.
So that's kind of what we've shown in the past, and that works great. But what we've added in snapshot 3, coming out in 1.14, is TLS pass-through, where you can have a fully encrypted session all the way from your external client all the way to your pods. And you're still using the Gateway API, and you still expose the Gateway API with the external IP, and that external IP can be used by multiple host names, and we essentially route the traffic based on the SNI in the certificate, and we send it to whichever relevant service.
Great.
It's kind of different model if you want to have end-to-end encryption, or if you want to kind of terminate at the gateway.
Yeah, I guess this means, the traffic within the cluster is encrypted. So if you're trying to achieve zero trust, this is one part of that puzzle.
Yeah. And we also have the option of using WireGuard, obviously, in transparent encryption for the kind of encryption of traffic that comes into the cluster, but I would be using kind of different certificates. So yeah, it's just a different model and different alternative for providing encryption of data in transit.
I think before we go into looking at the demo, there's a great question here from Douglas. So hi, Douglas. I don't think this is a silly question at all. Is the gateway API here the standard Kubernetes gateway API? And the answer is yes, right?
Yes, it's a fully conformant gateway API. Gateway API is an API, right? It's a it's a standard. And that's one of the reasons that, I think we're moving towards the gateway API instead of ingress. His ingress became a bit messy because everyone came up with their own annotations and their own ways of doing things. Whereas the gateway API provides a more consistent way of manipulating incoming traffic into your cluster. But yeah, our implementation is again fully conformant with one of the most recent API, which is version 0.7. And a lot of the demo actually have been inspired by a different implementation of the gateway API. I just looked at how they did this, and I could reuse their own kind of config for most of it. And that's the idea of gateway API, is to be more portable. Cool. Great. So let's go and show it. So I'm going to deploy a HTTPS web server, and that should just take literally a minute or so.
Might be worth making a little bit bigger if we can.
I can make it bigger. Yeah.
Great.
So again, I'm using some of the shortcuts on the side, which is just to something you will see in the lab. So I'm just creating all the certificates and keys that are going to be used as part of my web server, which is going to be just an Nginx web server. So I create my certs, my keys, and I also create a config map for my Nginx server configuration. And then I go and deploy it. And at my web server, which is now ready. It's listening on 443. And it's ready to go. Now we just have to configure the gateway, deploy the right TLS routing configuration. So if we just have a quick look at the config, again, hopefully you can see this well. So we have a gateway, which is a gateway of the type Cilium. And it's listening on port 443 for HTTPS traffic towards this specific hostname. And we are in mode pass-through. Again, we are just using the gateway API to route traffic based on the hostname. We're not terminating it at the gateway itself.
Okay, so would that be the alternative if it wasn't mode pass-through? The other option would be to terminate at the gateway.
Sorry, my headset decided to die as we spoke. Typical. Yeah, so yeah, the alternative, the other choice will be terminate. And that's the default one is actually terminate.
Right.
So we are now in pass-through, and we are using TLSRoute, which again, that's a new thing that comes with 1.14, and we are attaching this route to our gateway, which was defined up here.
And that TLSRoute, we can see through the API version, that's also part of the Kubernetes Gateway API, the CRD definition.
Yeah. That's right. And essentially, route to that host name will be sent to this backend, which is my Nginx service over port 443. That's pretty much all there is to it from a kind of TLS route configuration. And let's go. Right, so I've got my gateway, and I also have my route. And if we go ahead and actually double check, hopefully, yeah, my route has been accepted when it's been deployed, and it's been attached to my Cilium TLS gateway. So that should be working as we want. And if I go ahead and I've got my little shortcut here, if I make a curl request here, if I make a curl request over HTTPS using the certs I've created, and that should not be successful. I'm missing one bit. It's just to here, the gateway IP address. So one thing I should have shown is when I deploy the gateway, it picks up an external IP, which is typically either given to me by my cloud provider or by Metal LB or now by Cilium. Cilium now supports this feature. And we're just going to store this IP, and I'm going to run this command again, and this time it's successful. So you can see I've got 200 reply. I've done fully encrypted requests from outside the cluster to my HTTPS web server inside the cluster. And over, you can see the connection was over port 443. And you can see all the TLS exchange negotiation to, using 1.3 and the key. And you can also see that the SSL certification was verified okay. And I've reached my web server, which is Cilium Rocks, and that's it. That's just
great. We have a question from Russell. If we can go back to look at the YAML, why is the domain name repeated in the TLSRoute and the gateway? Could the gateway accept more than one domain name?
Yeah, so we can use, if I'm not mistaken, you can use like a WireGuard domain. Can you accept multiple domain names? I would have to try. I would have to double check and try.
I think it makes sense that it would accept a wildcard at least.
Yeah,
and then you'd be able to route to different backend services based on.
Yeah.
I'm not 100% sure of that, but
yeah.
Yeah.
Cool.
Also, just going to show very kind comment. The labs are seriously very good and fun to do. So great recommendation there and endorsement of these labs. Is this one of the one that's already published, or is this going to be live?
This one is a third Gateway API one. We are going to publish hopefully in July, around a few weeks time.
Okay, great.
So yeah, thanks for the feedback. If there's any other features you want us to build, labs you want us to come up with, just give us a shout, of course.
Great. Anything else we should say about the TLSRoute feature, or should we move on to the next?
Let's move on to the next one, if that's
all right. So just a reminder to the audience, if there's something particular in the list of possible items, then let us know. Otherwise, we'll probably just move on to, what do you want to cover next? Well,
I've got, as we're on the topic of encryption, I quite like the WireGuard as a tool to encrypt the traffic. And I guess I heard so when I was at KubeCon, I was talking to people around the ISO Venom booth, and many people were like, "Oh, I want a service mesh because I need to encrypt the traffic." And I was like, "Well, we actually do this. We've been doing this for quite a while." And we've had two ways to encrypt the traffic with Cilium. One is IPsec, which came one of the earlier version of Cilium. And WireGuard came in Cilium 1.10. And WireGuard is a more opinionated way of doing encryption in transit. Has, just decides strong protocols. It doesn't let you just customize your key, your algorithm and that kind of stuff. Just picks a very strong one, and it takes care of all the certificate rotation, and it's brilliant. It just works. Well, it works, but one thing that wasn't supported in WireGuard was there were some features which were not there. Right. So one, we didn't support layer 7 policies.
Mm-hmm.
So if you wanted to implement a network policy which was more, looking at HTTP path or any other layer 7 characteristics, that wasn't supported. And also, encryption was only from a pod to a pod. We couldn't encrypt traffic between two nodes in a cluster or from a pod to a node. And all these kind of limitations have been taken care of and are sorted in 1.14.
Brilliant.
So let's go and take a look. Right, so we're going to go and hoping that this demo will work because it was misbehaving a little bit before today.
I guess that's live demo, Jeopardy, and pre-release code, right?
Yeah. So let's have a quick look. It should come on shortly. So I've rolled out Cilium, and I've enabled encryption, and I've enabled WireGuard encryption. Again, I could have selected IPsec instead, and I've enabled this new feature, which is a node encryption feature.
Okay.
And I've also selected again the snapshot 3, which is one of the most recent snapshots. Right, the Cilium is healthy. Now, this is a bit where we're going to double check that WireGuard has been enabled. Has been, good stuff. So I've just logged on to the Cilium agent on my node, and I've just run Cilium status to double check that encryption was enabled. And you can see that's new, that you wouldn't have seen this in previous version. We now have this node encryption enabled because I've enabled that thing, that mode where the traffic between I've enabled WireGuard and I've enabled node encryption to make sure the traffic between my nodes goes through the encrypted WireGuard tunnel. And you can see the WireGuard interface here, WG0. And the key, and you can see I am peering with two other nodes. It's a 3-node cluster, so that Cilium agent is peering with two other nodes, and that's a port for the WireGuard tunnel.
Okay.
So we don't really have the time to show it today, but if I do this, if I were to capture the traffic on Cilium 1.13 or before, if I capture traffic on my WireGuard interface, I wouldn't see anything until I start generating traffic between my pods, right? Because it was only pod to pod that was encrypted. Now that we've enabled node encryption, all the traffic between my nodes should come through the WireGuard tunnel. So if I run a TCP dump listening on the WireGuard interface, I should see all the traffic between the nodes. And we're going to double check now.
And would we expect that to include things like Kubernetes API messages, maybe messages from the control plane node to kubelets, things like that?
I would assume so, yeah. Pretty much, it's actually quite chatty. Well, if we do, let's show this out. So if we just get the IP address of our nodes, see it's 172.18.0.2 and 3 and 4. So we're just going to install TCP dump. And now you can see I'm listening on the WireGuard interface. Whoops, and you can see all the traffic between my nodes, right? So all the traffic between my nodes is being sent through to the WireGuard interface and is being essentially encrypted. And as you can see, pretty chatty because my nodes are running some health check or whatever they are doing. It's all being encrypted. And again, we can, if you look at the transparent encryption lab we've got, if you run the same command, you will see nothing whatsoever until we start doing some pod-to-pod communication.
Right. Yeah. Great.
I mean, that's cool. Nice.
I think that's cool. Yes. Yeah. Now, if I remember rightly, there was another. Oh, there was the layer 7 network policy support. Is that?
Yes. Yes. So that was again. If I show you, actually, let's have a quick look. I'll show you in. This is a 1.13 lab. And I'll show you quickly what happens. So this is just the when you install WireGuard in 1.13 or before, in the installation logs, what you will see is this layer 7 proxy disabled due to WireGuard encryption. And essentially, again, it's because we just didn't support the WireGuard with layer 7 proxy, which means that you couldn't do any kind of layer 7 policy enforcement and visibility. Mm-hmm. And even if you were to try this morning, you would see in the logs of the agent, you will see an alarm saying, I'm running WireGuard, therefore I do not support this type of layer 7 network policies. And it just wouldn't work. So what we can do is try on 1.14 and see if it does work. So go back to the lab. And what I was going to do is just go through the Star Wars demo, as it's a good example of a layer 7 network policy. And let's do this live. So I'm hoping most people here are familiar with the Star Wars demo. But essentially, you've got a couple of different pods. And we first enforce a layer 3, layer 4 network policy. And we just check connectivity between our different pods. And who else do that? Works, and this shouldn't work. So we've enforced a network policy.
Basically, so that only Empire ships are going to be able to request a landing on the Death Star, right?
That's right.
Well, actually, at this point, can only make a request. It doesn't matter whether it's request landing or anything, because we're talking layer 3, 4.
Yes, exactly. Yeah. So, and it's based on that only applies to this endpoints, but it's only based on this protocol. So again, that's also that should have worked in previous versions, but it's when we apply the layer 7 policies that we would have seen an issue now. If I do this now and apply my layer 7 policy, go here. Go, just some warning, doesn't really matter. And our network policy is based on the HTTP traffic. We're only allowing posts and to this specific path. And we can see again that this should work as expected.
Russell's asking, why is Nico helping the Empire? I think, we're an open community.
So I've been essentially I'm getting the expected output, which is I'm preventing the TIE fighter from blowing up the Death Star, which is what you get here. So again, this is just a quick demo because we're limited in time, but the idea is really to show you that some of the restrictions that maybe would have prevented you from deploying WireGuard before are being removed. The whole data path for WireGuard has been rewritten as part of 1.14. So now there is very, for production workloads running, sensitive data, there's little reason not to use WireGuard, I would say.
Yeah. If you have a requirement to have all your traffic encrypted, one option is the kind of MTLS, from between services that service meshes would typically apply. But WireGuard is a much simpler thing to just roll out across all your nodes, and then all of your traffic will be encrypted, and you don't have to worry about certificates. It's a there are other reasons why you might want to authenticate services with each other, but if all you want to do is ensure that all your traffic is encrypted, then WireGuard will tick that box, and it's very easy to enable. All right. I've had a couple of other people join us to say hello to. So hi to Sadiq, who's watching us from Oman, I think another regular viewer. And we also have Artur, who is a first-time viewer, so welcome. Now, Artur also asked a question. I don't know the answer to this. I don't know if you do, Nico. gRPC pod load balancing support in 1.14.
Well, I guess not necessarily strictly eBPF. We've added in 1.13 we added support for gRPC load balancing using simply an annotation. That was a feature that came in with 1.13. I can put the link in shortly, but actually I've got my laptop open, so I'll show you, because we actually have a lab for this. Which is this one here. And we're actually using Envoy to apply to achieve load balancing. Again, that's typically something you may need a service mesh to provide that type of load balancing, because it's using multiplexing with HTTP v2, and therefore the traditional load balancing we get is not aware of all the different gRPC sessions. So we've implemented this in 1.13, and that's using Envoy under the hood. And I recommend you try the lab. It's there for you to do.
Yeah, great. We can add the link into the show notes later on. Or if anyone watching also wants to add that link, you're welcome to do so. The HackMD allows anyone to add useful material as we're watching. Great. Okay, so moving on. Do you want to cover the BGP things next? Is that a good topic to move on to?
We can do some BGP. Right. Let's see what we can show. Again, BGP. Just taking one step back, we've had different types of BGP support in Cilium for a few versions. And in Cilium 1.12, we kind of decided to go with gRPC as engine to support our BGP feature set within Cilium. And that supported IPv4 and IPv6, and that enabled you at the time to advertise the pod CIDR range to your top of rack router. And really that's the idea around BGP, is that connectivity between your cluster, which is managed, Kubernetes cluster managed by Cilium, to the rest of your data center network. And as advertising your routes over BGP. So that was great. And then in 1.13, we added the ability to advertise the service IP to the outside of the cluster using BGP. And now what we're seeing is the users are using our BGP and they need more features for better, faster convergence. It's more around usability, some of the features that have been requested as part of 1.14. So we have 3 new features, again, even 4 features that are available now on Cilium BGP. So we can start. And again, if there are any questions about BGP or anything else, just feel free to ask. Right, so let's have a quick look. So the one thing we've added, which is added to the Cilium CLI, so you may need to update your Cilium CLI if you're using BGP, or more generally, there's lots of enhancement to the Cilium CLI, is we've added a Cilium BGP command. And before this, if you wanted to find information about whether you have your peering connection ready, you actually would have had to go on the other side of your peering connection and run the show BGP command there on the other side. Cilium didn't have any kind of native commands for you to do that. So now if you do a Cilium BGP peers, you can see that this node is peering, its local AS number is 65,001. It's peering with this 172.0.1 peer, and that's its remote autonomous system. And the session is established, and we are receiving one route, and we're advertising one route. So for me, again, that's something that I love as a network engineer, is just this kind of BGP command to tell me information quickly. If you have to troubleshoot, you can run Cilium BGP peers and whether your session is up and running or not. That's handy.
So would that show us service addresses that we were advertising as well?
Not yet, no. So you still, if you want more information, like the actual IP that we are advertising, you would have to go on the remote side. Hopefully, I'm hoping that we'll add more of these commands. So for example, if I go on my peer, let's have a look. If I connect to my peer device, which typically would be a top of rack switch, I can run show BGP IPv4, and that tells me that me the peer, I'm learning 10.0.0/24 from this guy, which is Cilium, and that's a pod CIDR.
Maybe you can make the font a little bit bigger again.
Yeah, that's fine.
Yeah.
So we are. My remote is learning this route from Cilium, and I'm hoping again that the Cilium CLI will be improved to show the routes that are advertised or learned over BGP. But that's not quite there yet.
Yeah, fair enough.
Okay.
All right.
So, and actually, if you while we're on here, we can actually show things like timers. So in BGP, just like in most tunnel or peering session, you've got your keep alive and how often you tell your peer that you're alive. And then if you don't hear 3 keep alives in a row, then it means that you assume that your peer is dead. And you remove the routes from the routing table, and you try to reconverge. And by default, Cilium came in with a keep alive interval of 30 seconds. which was maybe a bit too high from, to kind of reconverge. Again, for more like production use cases, that's a bit too high by default, and there was no way to change it.
Okay.
And now we've added a new feature which lets you, if you go into my Cilium peering policy, I can actually now modify my peering times with BGP. So instead of, every 10, 15, 20, 30 seconds saying, hi, I'm alive, we can provide much more regular updates.
Okay.
We'll just, again, go back to the agent, and we run another TCP dump just to show this. Oh, no. Damn, I just reload my agent and just give it a minute. Okay.
Live demos. That's
live demos, yeah.
Maybe while we give that a minute, we can just go back to, and I'm not sure we do have a good answer to this, but Douglas asked a question about WireGuard, going back to the WireGuard topic, whether or not we have any performance benchmark information on the difference between WireGuard, well, turned on or turned off.
We did, and it's on one of the blog posts on, I think there's a Cilium performance blog post on Cilium.io where we did some comparison, compare with IPsec, for example, in Python CPU. Again, I can dig it out shortly. I would like us to create a more updated version. I think I was 18 months, 2 years ago.
Yes, that wouldn't include the node-to-node traffic that we're now encrypting. So yeah, it would definitely be worth redoing that testing, wouldn't it? All right, back to BGP. Hopefully the Cilium agents are back up again now.
Yeah, let's have a quick look. And so I just want to do a TCP dump on port 179, which is my TCP port 79, which is my BGP traffic. And what we should see is actually, I think it's a 15-second keep alive between Cilium. Here we go. So yeah, 53, and 15 seconds later, you have another keep alive between Cilium and the peer. So if we just change this down to 3 seconds, 9 seconds, we should see, and we apply it. Just reapply my peering policy. We should see very frequent keep alive now being sent. I should be a matter of seconds now. Just give it a minute.
I guess it might take a moment for that policy to apply.
Yeah.
Now it looks like it started. Yeah.
Yeah. So you can see now it's every 3 seconds we see keep alives. So I know it's quite maybe a bit nerdy, and but if you're using BGP in production with Cilium, I suspect you're not going to go with the default timers. You will want something a bit more, just a bit faster for convergence purposes. Yeah.
Great.
Any question on BGP? Or
I don't think we've got anything coming yet. There's always a little delay between us speaking and the audience seeing what's streaming on YouTube or LinkedIn or wherever they're watching, and then having the chance to type in any questions. So
yeah,
you never know.
Right. I'm just looking at some of the other features. I know
there was some multi-hop and graceful restart. There were also some other features in BGP, weren't they?
Yeah.
Graceful restart. I thought graceful restart seemed pretty interesting when we were talking.
Yeah, okay. So let me find my BGP again. And right. We're going to skip multi-hop. I think we'll run out of time. Actually, I've put some explanation here, but I can talk it through. And if you think about the way Cilium is deployed generally, Cilium is your, you get your data plane and you have your control plane. And the Cilium agent, when you reboot it, you don't want it to impact ongoing traffic. And currently, without graceful restart, as soon as you reboot the agent, because the BGP daemon is embedded within Cilium, your BGP sessions will be gone, and therefore the routes will be removed from your peers, and traffic will be interrupted. So either we need to decouple the BGP daemon from Cilium, or we do something else, which is using something called graceful restart, which is a BGP feature that has been available for ages. It's nothing new, but it wasn't available with Cilium. And graceful restart is really about gracefully recovering from a restart. So that if, let's say, if the Cilium agent restarts, you want your peer to be like, oh, I know it's just having a moment, it's just having a little restart. I'm not going to panic. I'm going to keep my session up, and I'm not going to remove the routes from my table, and I'm still going to send some traffic.
So it's almost like a grace period for that other end that's restarting to get it back together. Yeah.
Exactly. So let's see if we can show this. So I've got I got my session up and running. That's okay. And right now, just bear with me. I don't have any graceful restart. Sorry. I don't have any graceful restart configured.
Okay.
So if we go here, again, I am on the remote side, right? I'm not on Cilium. I'm on the Cilium peer, and the peer sees Cilium as not enabled in graceful restart, right? Which means that when I restart Cilium, because we're not in graceful restart, my peer will quickly determine that Cilium has gone down and will remove the routes from the routing table. So we can show this quickly. This is, again, that's the routing table, and that's my BGP. And I'm going to have to be quite quick here. So I'm going to reload Cilium. And if I run the same command again, you can see BGP is gone. Okay. And that route is gone as well from my routing table. So I'm running IP routes, and I'm running the show BGP IPv4. Right? There's no graceful restart, even though the Cilium kind of agent reload is like super quick. We've still had an interruption. We still remove the routes from the routing table. So not great when really we should decouple the data plane from the kind of control plane.
Okay.
So what I'm going to do, and you talk about grace period here, we actually have I need to find a configuration again. I think it's, well, let's find a graceful restart. So let's find the pull request in here. Okay, I'm going to zoom back in. So we're going to enable graceful restart again, and that grace period is set to 20 seconds. So we have 20 seconds where we accept that my peer is having a managed kind of event or reload.
Okay.
And also BGP configuration in Cilium is using the Cilium BGP peering policy. And I've just skipped this before, but essentially it's you specify which node is running BGP using a node selector. And you specify its own local AS number, whether it's advertising the pod CIDR to your peers. And then you have your peer-specific configuration, so the IP address of our remote end, the AS number for the remote end, and then you can add things like, your timers and stuff. So let's reapply the policy. And this time, when I run this command, it should take a minute. Right, so now the session is back up again, and Cilium is now in graceful restart mode. Okay, instead of being not applicable or disabled here, we are in restart.
Okay.
So again, we're going to have to be quite quick and reload the agent, and we're going to see what happens this time. Right, so I've run the same command, and during the agent restart, the root is still there, right? So it hasn't been removed from the routing table, still also here. And you can see here the root is described as stale, right? Because we know that there has been some kind of event. We also see, if I run this command around graceful restart, I also see the remaining time is 16 seconds. So we set this up to a maximum of 20 seconds. So we have this kind of 20-second window to accept this restart. And that's it. And when Cilium comes back online, it will tell the peer, I'm back online. You can mark this route back as as healthy. So we'll just double check now. And you see the route is not stale anymore.
Right.
It's valid, best. And everything is back to normal. So hopefully that makes sense.
Did you have anything before where it said things like the remaining time of restart timer is 16 seconds? I guess, we don't see.
No, you don't see this. Yeah. We're back in as everything being healthy, session being established, and cool. Everything tip top.
Great. Right, we've only got about just under 6 minutes left.
Right, Envoy. I know you wanted to see Envoy.
Yeah, let's try and get the Envoy daemonset. So I guess in previous versions of Cilium, we have Envoy embedded as part of the Cilium agent. And in this change, we're enabling Envoy to be run as a separate daemonset. So it's no longer having to be embedded in the same pod as Cilium, which improves isolation. It improves if there were a vulnerability in Envoy, that vulnerability gets exploited. only the Envoy pod gets affected. It doesn't necessarily affect, or it doesn't make it easy to transition from Envoy to Cilium, which Cilium is able to load BPF programs, and that's a pretty privileged thing to be able to do. So essentially, it's a security enhancement, I would say.
Yeah, and I believe that's the end goal is to make this the default model for Envoy on Cilium. Obviously, just coming out as now in 1.14, so it's going to be more in beta, I assume.
Mm-hmm. So it's an option. You can opt into trying it out this way.
Yeah. So, and actually, the way I'm going to opt in and configure it is using a new CLI installation mode that came out again just a few weeks ago, which is using Helm. So, again, if you think about how, if I do a Cilium install -h, by default, it's installing Cilium in a Kubernetes cluster. And actually, if you run Cilium install, it will call the Kubernetes API by default. And I think there were some situations where you're using Cilium install, and it's using the Kubernetes API, but then you want to make changes to your Cilium configuration using Helm. And there were some inconsistencies, right? Which I'm sure you have experienced yourself.
I've definitely battled against those inconsistencies a few times. So I'm really pleased about this change.
Yeah. And I think that just makes sense. So this will be default in Cilium CLI 1.0, which I don't know exactly when it will come, but that's meanwhile, if you want to try it now, you have to use this exports Cilium-_CLI_mode equals Helm. And if I run the same command again, you will see Cilium install is saying install Cilium in a Kubernetes cluster using Helm. So that's, again, a different type of installation mode. And I think that's probably going to be the favorite way of installing Cilium the future. So that's how we're going to use how we're going to install Cilium with Envoy as a daemon set. And by setting this setting, which is helm-set, Envoy enable equals true. And hopefully, again, if the demo gods remain good to me, it should work. So I guess the first thing we'll do is see if we have Envoy as a daemon set. So you can see Cilium Envoy. Here we go, that's ready.
Great.
And
so previously, you would have just seen the Cilium daemon set and the kubeproxy daemon set.
Yeah.
If you were not using kubeproxy replacement.
And we've also updated the Cilium status to reflect this. So if you deploy the new Cilium, the most recent CLI, you have a cluster with Cilium. If you run Cilium status, you will see this Envoy daemon set, and it will say disable using embedded mode, which is, again, that's the one that has been the commonly deployed one. But now we have our Envoy daemon set. It's okay, and it's here, and it's healthy, and I'm running a 3-node cluster, so see we are running 3 copies of Envoy, and that's all I've experimented with for the Envoy as a daemon set. I'm sure there are more funky things to do, but hopefully that shows a little bit what this new change entails.
Yeah. So we've pretty much got to the top of the hour. I think there was 1 or 2 more things that we didn't quite have time to cover this time. But we know there's more features coming in 1.14 anyway that we weren't even, prepared for today. So there's lots more to come. Hopefully we'll cover some more of those in future eCHO episodes. If you're watching and you have a last minute question, you're going to have to type really fast. Anything else that you would want to say at this point, Nico, before we wrap up?
No, thanks for having me. Thanks everybody for joining. Always a pleasure. But that's it.
I guess I'll encourage people to check out those labs. You've seen lots of nice demos that we've been able to show using these labs. Some of the labs that Nico's showed today, I don't think are published yet, but they soon will be. Lots of labs are already available, so do check them out. I think, like said, they're a fun way of exploring Cilium. So great. Thanks everyone for watching. Thanks again, Nico, for joining us. And everyone have a wonderful weekend. We'll see you soon.
All right. Bye-bye.